So I think this is working. We're actually a little bit past time, so we should probably get started. Hello, my name is Daniel Seaton. I am the co-chair of the research track for the Emoocs conference. I am very excited to be here and to be a part of this session, although I don't have a formal presentation. As you all know, and as even was mentioned this morning, dropout or stopout, as sometimes it's called as well, in the MOOC space is an issue that is currently, I'd say, plaguing many institutions. It's often something that's used to undermine MOOC movements, and that happens in Cambridge, where I'm from, quite regularly. So there's something that I was very excited to see, papers that came in for this, for the Emoocs conference, that there was a focus on dropout. And you're going to hear 4 great presentations today on that subject. We're probably going to have some time, too, for questions. Well, the format of this will go, people will give their presentations. We'll have questions at the end of each presentation. And then hopefully we'll have time for discussion at the end just to talk more broadly about the issue of dropout. So let me introduce the first speaker. This is Ruth Cobos. Your slides are up there. And she's going to talk about early prediction and variable importance of certificate accomplishment in a MOOC. Thank you, Ruth.
Thank you very much for this presentation. And it's a pleasure for me to be here to present this paper in the first session and to be the first speaker. I would like to do as best as possible. Okay, this research work is made in collaboration with Universitat Carlos III of Madrid. I come from Universidad Autónoma of Madrid. We are members of the same research network with the name Madrid. We are several universities from Madrid, and we are collaborating for a long time in Emoocs, MOOCs, and so on. So I'm going to follow the following outline agenda. Firstly, I'm going to introduce the motivation, the objective of this research work, and so on. Later, I'm going to expose the work that we made in collaboration with this institution in several phases. And finally, I'm going to conclude with a summary and future work. First of all, everybody here, I suppose, we know about a lot about MOOCs, the advantages and the disadvantages of MOOCs. And we know a lot about that when we start a MOOC, we used to ask, how many students do we have enrolled in the course? Maybe we have a lot, a massive audience, but following day by day, week per week, at the end, we would like to know how many students are going to finish or they're going to receive a certificate in our course. The difference can be a huge amount, no? A big data. So I suppose it's so common to have this kind of graph when we are supervising or managing a MOOC, that we are having less and less learners week per week. So the idea with this matter in mind was to work in the following objective. We wanted to predict as soon as possible who are the students that they are going to earn a certificate or not, in order to do at the end an intervention. This is the final objective. So for this matter, we thought in this is 4 questions. Firstly, how accurately can we predict certificate accomplishment based on data from students' interaction? Secondly, which machine learning algorithm performs best for this objective in this education context? Thirdly, when is the best moment for making the prediction? Is it possible to make an accuracy prediction with data from only the first weeks? And finally, which variables are more important for the prediction of the certificate outcome? Does the importance vary in the course progresses? In order to answer these 4 questions, we started, firstly, doing a previous work, reading about state-of-the-art related research work with this actual research work. And I suppose for everybody it's so common to know that not so much, less than 10% of the course is the completion rate for the MOOCs. And there are a lot of research studies about, for example, how to predict dropouts, or how we can predict the performance in assessment, or how to use these studies to do an intervention, how we can the TED student at risk in order to do an intervention. Taking into account all this matter, we decide, okay, we are going to focus this research work in early prediction, comparing different algorithms in order to finally to analyze the importance of variables or indicators. So we propose the research work in several phases, and firstly, I would like to introduce the MOOC, the course that we use for this research work. We use this course. This course is made by Universitat Autónoma of Madrid, my institution. We have this course at edX. We have nowadays third edition of this course. And as we can see, we have the course in Spanish nowadays, but we are doing some improvement to have this course in English too. We have a lot of videos, a lot of elements. In this slide, we can see the link to the first run of the first edition of this course. We choose this run because it was the run with the highest number of students enrolled in the course. We have more than 3,500 students enrolled in the course. More or less, half of these students were actively involved in the course, but only more than 400 students were involved in the last week doing exercises, watching videos, and so on. And we have only 64 students decide they could receive a certificate because they had the enough grade for that. This is a course of 7 weeks. Per week we have a lot of content in PDF, HTML, and we have at least one forum, and we have, of course, activities. Some of them are without evaluation, but at the end of each week we have an activity, an evaluation activity. The first and the last weeks are peer review, and the other weeks we have a questionnaire, a test of more than 20 questions. I suppose if you are working with edX, you know that we receive the data of the MOOCs in several formats, several files, JSON, data in MongoDB, and so on. And here I wanted to show only a line of a log, because we are going to use in this research work logs, the tracking logs of this course. We had a course in 7 weeks, so we decided to divide the data set in 7 weeks in order to generate 7 models for this course. We extracted 11 variables or indicators, and with this variable, we tried different machine learning algorithms in order to generate different predictive models, taking into account that we want to predict if the student they are going to acquire or not a certificate. The variables, we had variables in 3 types. The first type is variable related with learning progress. Secondly, we have variables related with volume and amount of learner activity. And finally, learner activity distribution. About the first one, we have, for example, progress in problem. That is, we take into account the grade received in all the assignments that the student made or along the course. Or progress in videos, we take into account the amount of time in a percentage of watching the videos along the course. About volume and amount of learner activity, we have variables related with total time, or amount of first session, or amount of events in the course. And finally, we have some variables related with homogeneity in solving problems or watching videos, or, for example, number of dates connected in the course. We started with the generation of these variables. And secondly, we decide, okay, we are going to generate, in order to compare several models with several machine learning algorithms. We use, for this task, random forest, generalized booster regression modeling, k-nearest neighborhoods, and logistic regression. In order to measure the performance of the models and the algorithms, we use these 2 metrics, the area under rock curve and F1 score. Because at the end, we wanted to minimize the number of false positives to make sure that most students are in risk of not getting our certificate will get a warning. We divided the data set in 2 parts, for the training and for the test, as you can see in this table. And we generate 7 training parts for the 7 weeks, and we use 4 algorithms in order to generate 4 models for this is 7 weeks. After that, we compare with the test the accuracy in order to detect what is the best, in this case, for this course, what is the best algorithm, the best machine learning model. And after that, we analyze for the selected model, for the selected algorithms, we analyze the importance of the variables during the course. Here we can see some graphs of the results. We have the comparison between F1 score and the area under the curve, and we have the performance results in the trained data set. As we can see, at the end, most of them are very good accuracy, but at the beginning, one of them is more or less the best, GBM. And if we see the same data, but for the training, for the test data set, we can see that GBM is the best all over the course, moreover, and we choose as the metric for measure the performance, the area under the curve. So we choose then the GBM algorithms for a model, and later we analyze the importance of the variables taking into account this model. Here in this graph, we have the 11 variables, and we have the evolution of the importance of each variable in the course. After the second week, we can see that the best one is the progress in problems. Okay, if we take into account this variable, we can have enough information to do a good prediction. This is the idea. To sum up, okay, in this collaboration between Universitat Autónoma of Madrid and University Carlos III of Madrid, we generate 4 machine learning models for predicting the certificate accomplishment in different time intervals, and we analyze the performance of the models. After that, the results suggest that the GBM model is the best one for this course, and in the analysis of the importance of the variable, we detected that progress in problems after the 3rd week was the best variable. We know that we work only with one course and one edition, so one of the following steps is to build more models, not only for this course. We are going to work with more courses that we have at Universitat Autónoma of Madrid, and moreover, we are going to work in the same area with more edition or runs of this MOOC. Moreover, we want to work in a more granular analysis. The idea is not to generate a model at the end of each week. We are going to generate a model at the end of each day, day by day. Due to MOOC heterogeneity, we could add additional variables like motivation or prior education. And finally, we are in the design of a warning system that we want to use in an A/B experiment to compare the use of this warning system and not use this warning system in results into different groups. That's all. Thank you very much.
So we have lots of time for questions. Anybody? Yes.
Yes, it's working. So your certificates are paid ones or free certificates?
No, when we say certification in this case are to pass a grade. They can be honor certificate or verified certificate. We don't distinguish between one of each other. Certification is to finish the course with enough grade.
But the participants pay the certificates?
The honor are for free. The verified certificate, only 64 paid for the verified certificate. But
64 it's paid?
Yes, they paid. The other, they receive an honor certificate.
Yes, I know. But do you have numbers for that?
I don't remember the number. I have to see the data, but I don't remember the number now.
Because they also count for completion, no?
Yes.
Could you go back to the slide where you have different parameters to see what was the predictor for the early weeks? The highest one.
The highest one is
Number of sessions?
Yes. The beginning number of sessions, but then is late. The biggest is this one, is progress in problems. The orange one.
Okay. I wonder what this would mean in the situation where the problems are not being made available
Yes.
to free users. How would we measure the completion of someone that was denied access to the problem?
If we don't take into account, if we don't take into account progress in problems, because we did another experience, if we don't use this indicator, the best one was number of sessions or number of events. Because if you see that one person is going inside the course every day or in a regular way, this person is going to finish the course. Okay, if we delete this one, number of sessions or days or events is enough to do a good prediction. Not as good as this one, but a good prediction. In this course, most of the students done the course only in order to know, because they wanted to know about Quixote, because this course is about the history of Spain in the Golden Age area, so they only want to know. They didn't want to have an evaluation, to have a grade, or to pass an exam, most of them.
Sorry, I have one question. Have you already started thinking about the, it's right here.
Okay.
Have you already started thinking about the kinds of interventions you could do based on these data? And I think also to John's point, there's sort of this dichotomy that in the early weeks, it would be one kind of intervention, then maybe later it'd be more problem-based or something like this.
Nowadays, we are working in the design of the tool for doing the intervention. Maybe in some months, we are going to have the tool in order to provide. Okay, the intervention is not possible directly. The idea is because we have anonymized data. The idea is, okay, with this anonymized data, we can have a dashboard where the teacher or the person in charge of the managing of the course, they can see, okay, this student is in risk because we can see that its indicators are low, and the tool is going to provide a suggestion. But the suggestion has to be executed, not by us, by the person in charge of the MOOC or by the teacher, the instructor. So maybe we can give per day a file with suggestions, but only the person in charge of the MOOC can do this intervention, to send emails or to put this information in a private dashboard per student. We have to speak more in detail about this matter with the person in charge of the MOOCs, with the organization UAMX office.
I'm Nicolas Senequier from IMT in France. Thank you for the great presentation. I think we all need this kind of research to better understand what goes on with our learners in our MOOCs. My question is regarding problem progress. Could you give us more information on how you define the variable? What's under that name?
Okay, we take into account per assignment that the student was doing, the grade and the amount of time that the student made this assignment. That's yes, the exercise. How many times the student did the assignment, and how many times, and what is the grade time by time. In order to have this information, we have a value between 0 to 1. More details about this matter, I can give you. I can show you later the formula.
Your assessment in the first week was a peer review?
Sorry? No, we take into account for the progress, the questionnaire, the test, not the peer review. We have to delete this part at the end because it was so difficult to take into account this part in the study.
Okay. If progress in the assessment is your top indicator, I was thinking it would make a good A/B test to have question-based assessment and peer review-based assessment as alternatives. alternatives and see which engages the students more to get them to continue on. Students generally don't like peer assessment, maybe peer assessment in week one frighten them away a little bit. So that can be tested with an A/B test. After students do a peer assessment in week one, with a question-based test.
We have to think more about how to do this A/B test. When we finish the tool, after to have the tool, later we have to organize to design the experience. So maybe we need more time to think. We have initial ideas, but it's important to be in contact with the organization, with the institution, to see how to do this experience.
Let's thank Ruth.
Thank you very much.
So our next speaker is Sarra Bouzayane. She'll be talking about predicting the at-risk MOOC learners using dominance-based rough set approach. I think we need the slides too.
So, hi everybody, I am Bouzayane Sarra, PhD student at the University of Picardie, Jules Verne in France, and the University of Sfax in Tunisia. Today I will present a method based on the dominance-based rough set theory in order to weekly predict or periodically predict the at-risk learner in the MOOC. That's right. Seven. Does not work.
This button? No problem.
Okay. So our motivation behind this method is the excessive dropout rate that may hinder both the pedagogical team and the learner. So we think that the early identification of the at-risk learner can be helpful for the pedagogical team to react at the right time, and also because of the dynamic information system that characterize the MOOC, and so that in the sense that information about learner are received periodically or by week, and also because the learner profile evolve over time. So here we think that the multi-criteria method based on the dominance-based rough set approach for the prediction of the at-risk learner can be helpful in this case. And here how our problematic here is first how to characterize the at-risk learner and then how to predict the at-risk learner. So here the plan is as follows. So we start by the previous works, and then I explain the method and how it can be applied weekly. Then I present the results of the experimentation, and I finish by the conclusion and the perspectives. So an important question that arises here is why we propose this approach, because in what it will be original compared to the previous work, because in the context we have already many works that have been proposed to identify or to predict the at-risk learner. So to answer this question, I start by presenting some works in the context of prediction in the MOOC. So the prediction models in the MOOC have many purposes, as the at-risk learner prediction and the intervention of the pedagogical team to answer a post. So among these works, we list the work of Balakrishnan, who applied the Markov chain using the classical attributes such that the number of threads viewed or the number of posts made on the forum. The Amnoué who applied the support vector machine using the classical attributes, but that are modeled in sequence, and then the length of this sequence will predict if the learner will leave the MOOC or not. Chaplot applied the network, the neural network, using the sentimental analysis of the forum posts, and Chandra used the regularized logistic regression using the type of forum. However, all these works and the other works are always faced to the problem of imbalanced data, and this problem results because of the unequal distribution of instances in classes in the phase of learning. In the MOOC, we are always faced to this problem because always we have the number of the at-risk learner. It's much more the number of learners who continue in the MOOC, and also because the non-intervened posts are much more than the intervened one. So to solve this problem, author either neglect it or propose other techniques such as the oversampling techniques or the classification boundary or grading the minority class instance with higher weights, but this is not always successful. So for this reason, the method that we propose is based on the dominance-based rough set theory, which is based on the quality of the training sample and not on its size, and also because it evolves the pedagogical team and the decision maker in the process of learning and decision making. So I present the method. The method is based on the dominance-based rough set approach called DRSI. So the DRSI is a supervised learning method dedicated to the multi-criteria decision making and inspired from the rough set theory. It allows to compare action using the dominance relation, and it takes into account the preference of a decision maker. So here the DRSI defines a data table called information table that is a 4-tuple S containing a training set A and a training set, a coherent family of criteria F that allows to characterize all of the training set, mole action in the training set. And for each criteria, we have a possible values according to the preference of the decision maker, and the function F that evaluate each action on the all of set of criteria. So this called information table, and here the decision maker intervene in order to classify each action in one of the predefined decision class. So we have now the decision table according to the preferences of the decision maker, and the approach DRSI propose an algorithm called DOMLEM algorithm that take as input this decision table and infer a preference model resulting in a set of decision rules. An example of the decision rules, this called preference model, and this method is proposed by Greco et al. So how we can apply this method in the context of MOOC? So we have proposed a method that consists of two phases. The first phase consists of the preference model construction, and the second exploit the preference model in order to classify the new learner, called potential learners, at the one of two decision classes. Here, the class L1 of at-risk learners and the class L2 of active learner. The first phase is made of three steps. The first is the construction of a coherent family of criteria. So here to construct this family of criteria, we established literature review in order to identify the most significant indicator in the context of at-risk learner identification. I don't know if... This is the list that we built. It consists of 8 static attributes and 3 dynamic attributes. So for the RSI, it makes difference between attributes and criteria, in the sense that criterion equal attributes plus the preference of the decision maker, that is here the pedagogical team. So study level, for example, is an attribute, and the preference of the pedagogical team is a scholar student, high school student, PhD student, or a doctor. And this list may serve as an exhaustive list for any pedagogical team, and it can modify it according to its preferences. So then the second step is the construction of a set of at-risk. This is the training set of at-risk learners of reference and active learners of reference. And here, 2 conditions have to be respected by this step, and that are first, this set has to be representative of the 2 decision class of at-risk learners and the active learners, and also it has to respect the cognitive capacity of the decision maker or the pedagogical team, because so it should be of high quality but of a reasonable size. So the output of these 2 steps, we have the decision class, the decision table. We have the first class CL1 of at-risk learners, the second class CL2 of active learners. The action here are the learners, and the decision maker is the pedagogical team. And the third step is the inference of a preference model using the DOM-LEM algorithm. So how we applied it periodically. So we have here the MOOC progress and the 2 phases. The first, the week I, so we start here by using the criteria family that it was already built at the first week, and then we construct the learner of reference of the week WI, and after that we construct the decision table related to the week WI, and then we apply an incremental phase that adds the training set of the week WA with all the training sets of the previous weeks. And here we have proposed an algorithm that is the extension of the DOM-LEM algorithm in order to incrementally calculate the training set and the decision roles in order to not have rules that are not consistent. So the algorithm is published in the Comics 2017. And then we have the preference model. We verify the consistency of the rules base, and then we classify the potential learners of the week WI+1 of the next week. And this method should to run in an iterative manner. For the experimentation, this method is tested in a French MOOC that lasted 5 weeks, and this started by 2,360 learners, and it was animated by 1 tutor and 2 pedagogical assistants. So in the 5th week, in the 5th quiz, we are only 10% who continue this quiz, so we are also 90% the rate of dropout. There are also examples from the decision table from each week. and the preference model inferred. For example, for the first decision rules, it translates as follows. So if the learner's motivation to participate in the MOOC is at most to discover the MOOC concept, and the score that he obtained at the end of the first week is at most 6, then the learner is at risk to drop out the course in the second week of the MOOC. So here, the extract from each decision table and preference model of each period of the MOOC. So here to validate to evaluate the preference model or the prediction quality of our method, we calculated the F measure, the precision, and the recall in two ways. The first is the non-incremental approach. It's when we take into account only the data from the previous week, and the incremental approach when we take into account all the data from all the previous weeks. So here we focus only on the red values because the F measure is always already the harmonic value of the precision and recall. So here we remark that we can note that from a week to another we have the quality increases, and also the difference between the incremental and non-incremental also increase, and that's because each week we have, for the incremental approach, we have a training set that is more diverse and richer, and also larger than the non-incremental approach. So we stay now in the incremental approach. Here we calculated the F measure and the accuracy. And here we note that for example, the F measure of the first period, it was not very satisfactory because the existence of the lurkers who still active in the first week, but they have the intention to leave the MOOC. So we have, in this case, the false positive rate that is very high and which decreases the quality of the prediction. And also, this is not the case for the accuracy, because accuracy is not, it's not based on the false positive, just calculate the correct instances. And also, in the third period, we start to have the better prediction, because in the third head we have the MOOC proposed a peer-to-peer evaluation. So here we start to have the more serious learners. And the same remarks for the accuracy. So to conclude, our contribution here is to construct a family of criteria that permit to characterize the learner who are at risk. And also we have proposed a periodic multi-criteria method for predicting the at-risk learner. Now the question, what is the solution for the at-risk learner? What solution proposed for the pedagogical team in order to intervene to avoid the learner leave the MOOC? So our perspective is to integrate a third decision class, CL3, of LIDA learners, and then to propose a recommended system to personalize the support of at-risk learners, so to recommend a personalized list of LIDA learner to each at-risk learner. And that's all. Thank you.
So we have a few minutes for questions. I'll start with one. Can you go back to slide 9? I may have missed this during the talk. But can you go back to slide number 9?
9.
Yep. So yeah, this is fine. I may have misunderstood when I was looking at things, but in week 4 to 5, so what are the 2 points diverge?
Yeah, because in the first week we have the MOOC proposed peer-to-peer evaluation, and so for the second we have based on the score that is obtained in the fourth week, but in reality those who participate in the fourth week does not participate in the fifth week, and so this because
I think I understand.
effect
Yeah.
of the peer-to-peer.
Gotcha. Well, that's good. I was hoping there was like a pedagogical explanation. Anybody else? I mean, I'll add another comment. This is something that myself and colleagues talk about quite a bit. In the early days of dropout prediction, we focused entirely on like, here's a course, and did we really understand what happened with dropout throughout the entire thing? But really, we need to be asking the question about weekly, right? Like, so if we're able to find prediction and able to say, here are the learners who are in need of support, and do that on a weekly basis or even a daily basis, like that's the ultimate goal, right? So this is very exciting to see work like this that's trying to pinpoint it that way.
Thank you.
Okay, anybody else? All right, let's move to the next speaker. Maxim Skryabin from, I don't have your thing listed here, sorry. But he's going to talk about types of dropout and adaptive open online courses. Thank you.
Hello. Okay, when uploading the presentation, I just introduce myself. I'm Maxim Skryabin. I'm from Russia, and I'm working at an educational platform that's called Stepik. So it will be the view from the other side. And I want to discuss dropouts in adaptive courses. But first, I want briefly to tell you about Stepik. Because Stepik is an educational platform that is one of the largest in Russia and I think in the Eastern Europe. We focus more on IT and STEM courses, and we have special assignments, for example, for automated code grading, for automated data grading, even for Linux server. But we also have a different type of assignments, for example, for peer review. I really was glad to hear the same issues from the previous speakers about different platforms, for example, for peer-to-peer assessment, and it is so-called killing quiz because a lot of students leave courses after peer-to-peer assessment. About prediction according to the first week activity. And continuing by Stepik, so we introduce not only massive open online courses, but also different type of courses. For example, small private courses or online programs that include a set of courses. Also, it is possible to use our platform for contests and competitions, and also we have adaptive online courses, and I will talk about the last part. Adaptive learning is an umbrella term because when we talk with each other, different people understand adaptive learning in different ways. I wanted to figure out several types of adaptive learning systems. I believe that it is not the full list, so if you want, you can add some points to these approaches. One of approaches is rule-based systems, where we need to develop some rules, for example, with instructional designers, how we move through learning content according to activity on the current learning objects or previous one. The next one is not, I think, very popular, but sometimes it happens, is preference-based systems, that is use learning preferences and learning styles. The third one is memory-based systems. For these systems, So it's typical, for example, in systems where you need to learn some contents, for example, when we learn foreign language using flashcards. And the last but not least, test-driven systems that use idea of computer adaptive testings and implement this idea into educational context. And our adaptive learning systems built as a test-driven system. So the idea for this type of systems, so we use adaptive loop. We start with initial ability estimation. Then we select appropriate learning content for according to this estimation. Then administer this content and capture answer. And based on this information, update ability estimations and check stopping criteria. So if they do not satisfy, we go to selecting next items. So this loop is common for adaptive testing and adaptive learning, but the differences in details. The first one, how we select learning content, because so the main difference is in the goal, because the goal for adaptive testings is to measure ability as accurate as we can. So we need to reduce measurement error, but the goal for adaptive learning is to increase this ability. So we do not assume that this ability is stable, is constant. And this implies differences in each stages. For example, when we select item, to reduce measurement error for adaptive testing, we need to select such as content, such of quizzes that students can solve with probability 50-50. But for adaptive learning, it can frustrate learners. So for these purposes, this probability of not solving quizzes is decreased. And again, about stopping criteria, because for adaptive testing, we use accuracy of measurement. And if it is okay, then we quit this adaptive loop. But for adaptive learning, we use some threshold that is not less than some value. And on the right part of my slide, it is interface of our adaptive course. And unlike a typical adaptive course, students not only can solve some problems, but also evaluate some lessons as hard or easy. So in this case, it's about their self-confidence. Yes. And when we got some data from our adaptive learning system, we started to think when students finish their adaptive course before they solve necessary amount of quizzes. And unlike my previous speakers, so this is, I think, the previous part, because I believe that we first need to understand why and when our learners drop out the course. Then we try to use this data to predict this dropout. And then with instructional designer, we use we design interventions for our learners. So for this research, we were interested in what type of students exist in the sense, I mean, from the students who dropped this course, and another, what their latest interactions on the platform before they dropped the course. And about related work, the dropout is one of the hot topic for MOOC research. And it is well known that dropout rate, completion rate in MOOCs is very low. And so according to the meta-analysis of Jordan, it an average of 6.5%. And there exist different reasons for students drop out. And actually, after my quantitative research, we did some research with questionnaire when asked students why they drop out the MOOC course, and most of them told us that it is lack of time. I do not believe that this is a real motivation, but because it was a questionnaire, we couldn't clarify what's really the reason. Again, there exists a bunch of researches how we classify students inside of MOOCs according to how they use the MOOCs. For example, Kuzitsas identify 4 clusters, completing, auditing, disengaging, and sampling. And some other research identified different type of clusters. So some of them can be very similar, but some of them are not. But I think the main one is that the people who are trying to use this course, the people who just listen to this course, who more actively participated, and some of them are disengaged students. About adaptive MOOCs, it's not so many research about dropout, but there exists several research about some prediction. For example, there exists research about dropout from instructional text and some predictions for these cases. And next one that is related with intelligent tutoring systems. This part of researchers do not focus on dropout rates, but they focus on students' behavior inside of intelligent tutoring systems. So there exist some cognitive, metacognitive, and affective factors that influence students' behavior. For my study, for this study, we chose adaptive Python course. This course contains over 350 quizzes for Python programming that is graded automatically. And it has over than 4.5 thousand of enrolling students. But because our adaptive system constantly develops, so we just chose shorter period that doesn't relate it with summer and winter vacation. So it's only from September 1st to December 15th. And we got a final sample that contains over 600 students and over 10,000 interactions between students and lessons and quizzes. And to find some metrics, so we use the following metrics for our students that are related with 3 groups of students. The first one is performance, the second one is self-confidence and engagement of students. For performance, you can see that we use number of attempts for last lesson. So this is lessons where students drop it up. And more smooth metrics that's related with solving rate of last 3 lessons. And the third one, so I didn't mention earlier about solving time, because our systems mostly built on how quickly students solve quizzes. So if this logarithm of normalized solver time is equal to 0, then students solve this quiz average as other students. Otherwise, if it is higher than it is, his performance is worse. And so this was measurements for performance of students. Another is about self-confidence. So it's related with their self-evaluations of lessons as difficult or easy. So it is not asking about, in this case, we do not capture their performance on their lessons, just capture how they evaluate. And the last but not least is about engagement of students, so how much they use adaptive engine. So, and we selected two metrics for this, number of past lessons. So how many lessons was recommended to students, and total solving time, so how much time does they spend inside the adaptive learning system. And to clusterize our students, we used standard techniques. So it was K-mean techniques. And because we do not know number of clusters, we use silhouette metrics to identify optimal number of clusters. So this is the formula provided, and here is A is average dissimilarity of of students with all other data within the same cluster. So these metrics show us how good this label fit to current students, I mean cluster label. And B here is the lowest average dissimilarity to other clusters. So in this case we use information about other clusters. And for last three reactions, we just use descriptive statistics and results. Well, results was not overwhelming in general, but again, so we made some conclusions for them. So we identified 3 clusters. And the last 2 clusters related with student self-estimations of lessons. So if students estimate lessons as easy or they estimate lessons as difficult. Yes, and here you can see bold values. So these bold values show us that this value is statistically significant from other values for other clusters. And for first cluster, here we can see some performance metrics, but not all of them, only 2 of 3. So this is for students who perform enough good in our adaptive learning system. The most interesting result for this purpose for me was that there is no differences between engagement metrics. So for our purpose it doesn't. We didn't have differences for how many lessons do they pass and how long they used this adaptive learning engine. So just performance and self-evaluation. And another is about descriptive statistics for last 3 reactions. Here I added not only that they solve lessons, but also about their performance if they solved quizzes of lessons fast or slowly. And the bold one, you can see that the most frequent situations that students evaluate lessons as hard, and the next one that their performance is lower than average. So this is for disengaged students. And for this, For these cases, For these cases, I remembered optimum motivation law of Yerkes-Dodson and flow theory, because we always have students who can be frustrated when their challenges is higher than their ability, and for students that can be bored in the others. So this is very high hope for adaptive learning system to decrease both of these groups. But according to the descriptive statistic from previous slide, the most focus should be on disengagement students frustrated students whose performance is not good, or who evaluate the content as very difficult. And some summary, because you can notice that we do not only use performance metric, and then that there exist some metrics for their self-evaluations, and this is another deeper topic that related with metacognitive skills. So it's not only about knowledge domain, but also about motivation and metacognition. And another summary, that when we focus on disengagement students, I believe that we should more focus on frustrated students more than students who bored with content, because students who perform very well, then they can go further and can get more advanced in content for this case. And lucky us, because we present educational platform, and we have one benefit from this: we can redesign very quickly. So we just started to redesign new adaptive design engine that is more focused on frustrated students. Thank you very much for your attention.
So we have time for questions. I had a clarification. This was for Python code, right?
Yes, this is for Python course. So for this course, students should write their programming code according to task.
Okay. So the actual, like the problems that are being fed adaptively are coding tasks.
Yes.
Oh, that's very cool.
But they can do this in the software and then just copy it, or they can do this online as well.
Okay, nice.
We are talking about how many participants?
So it is not much, because we we chose time period from September to December. So it is self-paced course. So we don't have deadlines, and well, we wanted to move more and more to self-paced course on our platform, because our data showed us that it is not so many differences in sense of activity, at least for our students that is on our platform.
I have maybe one more question, which is whether it's well, you may not know officially, but whether it's a skill gap or, say, a bad problem, right? That's something that we face with MOOCs and the institutions I've worked with, is that sometimes you can have a really miswritten problem, or it's just slightly off, right? Like you forgot a few words in a description, and so it causes students a lot of trouble. And so in coding, I can imagine there are certain exercises that do it as well. So are you interested in like classifying the kinds of problems that people have in that case?
Okay, I will split up your questions into two.
Sure.
One, okay? Because in our program, we have a lot of introductory programming courses in different languages. And for example, we did research on for our course that is not adaptive course, it's just linear course. And we wanted to find dropout into these courses with dropout rate, how it changed from quiz to quiz. And we got very interesting result because the first, I think, week or maybe half of week, so there exist very easy questions, multiple choice questions, some matching questions that's related with some programming and R. For example, what will be output if you have this kind of code. But then when we had the first quiz for first programming quiz, dropout rate increased almost 60%. So we lost a lot of students only the first quiz. We called this quiz as killing quiz because our students was moved out from this course. And when we gave this data to our teacher for this course, he decided to redesign this course. So he started to provide more motivational phrases. He added automated feedback in his quizzes, so it is decreased a little bit, but not so much. And another one, because I wanted to split up into tutors, about clusterizing of items. So we didn't do this directly. So we keep some data if items is difficult, because we need this data for our adaptive learning engine. But we didn't use it into two directions. I think biclusterization will be interesting as well.
All right, let's take Maxim one more time.
Thank you.
And our next speaker is Ignacio Despujol. And I don't have your title. My laptop went to sleep. And he'll be talking about the effect of free certificate discontinuation and completion rates of MOOCs.
Hi, I'm Ignacio Despujol from Universitat Politècnica de Valencia. For those of you who are not from Spain, Valencia is in this coast of Spain. We are a middle-sized university by Spanish measures, perhaps big in other countries. We are near the sea. We have around 33,000 students and 2,400 teachers, and I am the MOOC initiative coordinator of the university. We have been doing MOOCs since 2013. We started with Google Course Builder, and now we have two different instances, one with OpenEdX that we call UPBX, and we are members of edX.org. Most of our courses now are on edX.org, but we still keep our platform for first launch of our courses and for local courses. And we route all our digital marketing efforts, we do them with our platform. Then we reroute the traffic into edX. Our MOOCs are mostly XMOOCs. We use a video format like this one that we call polymedia. It's because we have some studios to make it fast. And most of them are based in videos between 1 and 12 minutes, one quiz per video, then one exam per unit and a final exam. We have PDF to download, and the forums, like most XMOOCs. In our MOOCs, we give the teachers some kind of indication of when they do the material. On average, we have 1 hour of video per week. That is something for 3 hours of work for the students. We ask the students to work between 3 and 4 hours per week. In some MOOCs we have 6, 5, but most of them are 3 hours per week. We ask them, most of the courses as 50% grade to pass, And now we have most of our MOOCs, we first run them synchronously, and then we move them into self-paced, because we try to give the learner the opportunity to access the MOOC the most time and the time he wants. That has advantages and inconveniences, but now we think that there are more advantages than inconveniences. Our big numbers is until now we've run 50 MOOCs. At the end of the course of 2017, we'll be running around 55 or something like that. 220 editions, different brands of the MOOCs. We have had an enrollment of almost 800,000, and with a passing rate of 8.8. We started with a passing rate of 12%. Then we entered edX, it went down a little bit to 10.6 or something like that, and now has happened what I'm going to tell and what this speech is about. On January 2016, edX, in a move to be able to achieve economic self-sustainability, edX decided to discontinue the free certificates and keep all the content free on MOOCs, but the certificates, the verified certificate, keep only the paid certificates. We argued with them that was going to have an impact on the completion rate. They told they had made their surveys with students and their studies and the tests, and they thought that was not going to be as much as the increase in the number of verified certificates we're going to have, and that way we're going to be nearer the self-sustainability economically, because MOOCs are, expensive. We make them cheap, but even so, that's quite a lot of money. So I decided to compare the same 24 courses, the run of 2015 and the run of 2016. In one of them, we had honor code free certificates, and the other one, we didn't have them. And I took the synchronous editions, the ones with teachers, not the self-paced, to be able to compare the same thing, with a total enrollment of almost 200,000 people, and a little bit more in the 2015, a little bit less, perhaps 110,000 in the 2015 and 90,000 in the other one. And these are the results. Here on the left-hand side, you can see the completion rate in 2015 around, this is the median, not the average, but it's a little bit lower. It's 10.2, 10.3, and now, later in 2016, we went down to 5%. And with the verified certificates, we had a little improvement. The spread is the same, but we went from, let's say, 0.6 to 0.8 or 0.7 to something like that. This is the median that is lower than the average, because the bigger courses perform a little bit better. So here we have all the different courses. You can see here superimposed the 2015 and the 2016. We had some courses that didn't lose too much, but other courses lost half of their completion rate. We cannot say certification rate because in 2007 and 16 there were no certificates, but and on average we went half to the number of people who completed satisfactorily one course. For the verified certification rate, we can see what in some courses we didn't lose anything. We didn't win anything, sorry. In other courses we win a little bit. In other courses we win. Our average completion rate went from 0.7 on average to 1. So in some courses we went from 1 to 2, and other. In some of them we even lost a little bit of verified certification rate. Of these courses, I can tell you that if we separate our courses in career-oriented courses, like for example, mobile devices applied to territory measurement or introduction to project management or something like that, and more academic courses on algebra, maths, physics. And the ones on career-oriented experimented a 1 point, it increased something like 45%, and the other ones stayed almost the same. Increased something like 25% on average, with some of them even going lower. Which can be the solution? We think we are going to try batches. I haven't found any article, any literature that says that studies what is the effect on badges. There's one on edX, but it was done before removing the free certificate. So they concluded that the badges had no effect, but then the learners had the free certificate. I would like to know now that they don't have any free certificate. And the only thing I found is in the Karting Year in Review 2016, they don't address this issue, but they have the numbers for several of their courses. And they have one that they have badges on edX. This one is about mining. And on this one, the losses on completion rate has been lower than on the other course they have without the badges. So I think that we would go for a try. The problem with this is that you need to do it without losing income from the verified certificates. You need to give students that don't need a certificate something that motivates them to say, I finished the course, but you have to be very careful not to cross the limit where they use that for demonstrating they've done the course in their curricula or and then you lose this income. So here are the conclusions of my speak. I think that completion recognition is a strong motivation for the ones that start the course, because we would need another talk about who are the ones who take a course, because they say that MOOCs have a big dropout rate, but probably half of the people who enroll in a MOOC never appears on that. So that shouldn't be considered dropouts, because they were intending to do the MOOC, but they never show up. But this is another story. Then we need to find a way to recognize completion without affecting the income. And free certificate discontinuation has had an impact on our verified certificate, but mostly in our career-oriented courses. For the other courses, the increase has been less. It's been 45% for the career-oriented courses, around 26%, 27% for the more academic courses. And that's all, folks. Yeah.
And we have a few minutes for questions.
Ignacio, so you're going to be looking at a badging system that is internal in the platform versus one like Open Badges, which is external?
I think we're going for Open Badges. The thing is that edX has a way to integrate Open Badges with the courses, but it's done through certificates. So if you don't have free certificates, you cannot integrate directly with the platform. We are going to research a little bit using JavaScript to add a piece of code in the page of updates, where if you've got your certificate, it shows there. If you got your badge, it shows there your badge about the course. So you can. We will do it with Open Badges. Create the badges on our site, and then put this piece of JavaScript. So if one student has finished it, he can see it on edX. With OpenEDX, we could be doing other way around. But as probably 85% of our courses are really run on edX, we should go to a solution that fits on edX and also on OpenEDX.
Right. So those badges will only appear inside the course?
No, they will be inside the course, and they will be in your backpack or Mozilla backpack if you want. They will be Open Badges. An Open Badge is really a file you keep on internet on a server that can be accessed through anything. And we will use the Mozilla API to let the student upload it into Mozilla backpack, and then they can share it with LinkedIn or with Facebook or with whatever they want.
So what's your strategy to differentiate the badges from the certificate?
As far as the Spanish-speaking market, in the Spanish-speaking market, the enterprises or the governments doesn't accept a badge that looks like a badge. That's not something the kind that it looks like a certificate. So we think that it's not going to affect this kind of people who need it to show it in their curricula, and they are willing to pay. We want to to address those people that are taking the MOOC and would like to have something, because we tell them, you can print your progress page and use it, but it's not the same. That showing something that you finished the course, you are great, and that's what we're looking for.
I did a similar study of our courses when the certificates were dropped. I didn't publish it, but very similar data to what you.
All right, thank you, John.
Any other questions? All right, well, let's just thank all the speakers and thank you all for coming to this opening session for the research track. Thank you.